So today I am going to start another chapter, that is partial differential equations. Okay, partial differential equations, and in short, I can write PDE. This I am going to start. Okay, so if you take combined complete differential equation, then it is ordinary differential equation, partial differential equation, special function, and green function. And then when the dependent variable is more than one, it may be two, it may be three. So the dependent variable is more than one. And what will be, so most of the time, your independent variable will be depending on more than one function. For example, size the independent variable and it depends on independent. So for example, psi is the uh, dependent variable, and in Schrodinger equation it depends on x, y, z and t. So there are four variables on which it is depending, so that equation is partial differential equation. So the Schrodinger equation is a partial differential equation. Okay, similarly you have another equation which is Laplace equation. So suppose I write in two dimensions, the Laplace equation will be like this. In 2D, the Laplace equation looks like this. So you can see that there are two independent variables. There are two independent variables, so it is a partial differential equation. It is a partial differential equation. Okay. So when you have more than two or more than two independent variables, then the equation is not uh, ordinary, but it is partial. And one more thing I want to tell you about the solution that we are going to discuss will be the method of variable separable. So we will discuss this method of variable separable technique. What is this technique? So this technique will convert the partial differential equation into ordinary differential equation. The variable separable method will convert the partial differential equation into ordinary differential equation. And once you convert the partial differential equation into ordinary, for ordinary we already know the methods. So concept of ordinary differential equation will be used in this partial differential equation solution very frequently. So the variable separable technique is conversion of partial differential equation into ordinary differential equation, and we will be following this method only. Okay, so all we have to do is to follow the variable separable method to solve the partial differential equation. Okay, so let me introduce you with that technique. So if this much is okay, so the method is like this. The method of variable separable is like this. Suppose you have psi as dependent variable, and suppose it is function of x and y. So the technique says write it as product of only function of x and only function of y. This is the technique, that if psi is function of x comma y, then write it as a product of capital X into capital Y, where this is only function of x and this is only function of y. So suppose psi is function of r, theta and phi. So what you have to do is you have to write it separately as function of r, function of theta and function of phi. Okay, so this is capital theta, capital R and capital. This is only function of small r. This is only function of small theta and this is only function of phi. Let me write phi like this, r, theta and phi. So this is the method, and using this, here two ordinary differential equations will be made and here three ordinary differential equations will be made. And we already know how to solve the ordinary differential equations. So this is the method which we will be using as a variable separable method. So let me take one equation just to explain you that how it works. Let me take an example. Del u by del x is equal to 2 times del u by del t plus u, and condition is given that u of x comma 0 is 6 e to the power minus 3t minus 3x, sorry, minus 3x. This is the condition that is given. So you can see there are two independent variables, x and t. So you can decide that u is function of x and t. Two independent variables are there. So this equation is partial, not ordinary. So the method says write this as capital X as only function of x and capital T as only function of t. Substitute back in this equation. So it will become t times del x by del x is equal to 2 times del u by del t. So it will become capital X times t dot, and I can also write this as x dash just to make it very simple, you understand. Okay, so dash I will be writing for the derivative with respect to x and dot I will be writing for the derivative with respect to t. So it will become t times x dash is equal to 2 times capital X t dot plus xt plus xt. So
Please explain again how you have written this last equation.
just substitute this 1, this 2 into 1. Put the value of t in equation 1. So what will happen when you will write del u by del x? So it is partial derivative with respect to x. So t will come out and the derivative of x will be taken. Then equal to 2 times capital X will come out and derivative with respect to t will be taken and plus xt. Okay.
Okay, sir. Yes, sir.
So now divide the whole equation by capital X and capital T. We can do that. So it will become capital X dash by capital X is equal to 2 times t dot by t plus 1. So you can see that this side is only function of x and this side is only function of t. Correct? So this side is only function of x, this side is only function of t, and both are independent variables, but they are equal. So that means this side will not depend on t, this side will not depend on x. So if both are equal, that means they will be only equal to a constant. Only constant is the common ground. So they will be equal to a constant. So x dash minus lambda x will be equal to 0. This will be the first equation. And second equation will be 2t dot by t is equal to lambda minus 1. So uh, this will become 2 को यहाँ ले जाओ. So this will become x dash is equal to lambda x. So d capital X by x will be equal to lambda dx. So log of x is equal to lambda x plus c1. So x is equal to a times e to the power lambda x. Okay, correct? And similarly, this side will become dt by t is equal to lambda minus 1 by 2 and dt. So log of t is equal to lambda minus 1 by 2 t plus c2, and t is equal to b times e to the power lambda minus 1 t by 2. Correct? So what will be the value of u? Both will be multiplied. Capital X and capital T is the value of u. So it will become some k times e to the power lambda minus 1 t by 2. Correct? Apply the condition. So put t is equal to 0. It will become k uh,
X term is also.
into lambda x term also e to the power lambda x into e to the power lambda minus 1 t by 2. दो term है ना? So this will be k times t is equal to 0 e to the power lambda x. So if you compare, k will be equal to 6 and lambda will be equal to minus 3. K will be equal to 6 and lambda will be equal to minus 3. So what will be the final solution? U of xt will be equal to 6 e to the power minus 3x and e to the power minus 2t. This is the final solution.
हेलो सर. सर
हाँ, yes.
सर यहाँ ए और बी कैसे कांस्टेंट सेलेक्ट किए हैं?
अच्छा, यहाँ पे ये
हाँ सर, यहाँ बी और यहाँ ए कैसे सेलेक्ट किए हैं?
जैसे log t लिखा हुआ है तो t लिखोगे तो क्या हो जाएगा? e to the power c2 हो जाएगा.
यस सर, यस
e
सर.
to the power c2 को b लिख दो, वो भी तो एक कांस्टेंट ही है.
ओके सर.
ऐसे ही उधर a लिख दो.
ठीक सर.
सर ये UXT इक्वल्स टू K वाला एक बस है, प्लीज रिपीट करें.
ये
लास्ट थर्ड सर.
ये ना,
UXT इक्वल्स.
हेलो,
यस सर, इसके ऊपर
ये वाला
हाँ ए वाला बोल रहे हैं।
तो इन दोनों को मल्टीप्लाई कर दो ना। ये देखो यहाँ पे u है x इंटू टी, तो आपको x भी पता चल गया, t भी पता चल गया, तो जस्ट दोनों को मल्टीप्लाई कर दिया, फिर a इंटू बी को नया कांस्टेंट k लिख दिया।
ओके सर।
दो a इंटू बी लिखने की जरूरत नहीं है ना, मल्टीप्लीकेशन विल बी अ कांस्टेंट, सो आई हैव रिटन अ न्यू कांस्टेंट k, करेक्ट?
यस सर।
So this will be actually the idea behind the partial differential equation which we are going to discuss. So if this much is clear, then next things will also be clear. So अगर आपको ये समझ आ गया हो तो we can proceed further. I hope everybody has noted it down.
यस सर।
Or okay. And the method is okay. Partial differential equation means more than two independent variable, and then you have to write that dependent variable as multiplication of independent variables like this, substitute back into the equation, and then I gave you a mathematical argument that because this is only function of x and this is only function of t, constant can also be considered here also or here also, that is not a problem. So there are variations here and there are variations here and there is equal to sign, and both are independent, they have nothing to do with each other. That means both can only be equal to a constant. I hope you understood this mathematical argument. This will be used again and again. Okay, so let me now consider a situation. Let us consider a situation in which you have a wave equation which is one dimensional and undamped. One dimensional undamped wave equation I am going to consider, and this I will be solving using the concept of partial differential equation. The example is like this. Suppose this is a string and here x is equal to 0, here x is equal to L, that means length of the string is L, and suppose this is a wire string and this is attached strongly so that it does not, the ends are tight. Okay, the ends of the string are tight. So suppose you give a small displacement, so what will happen, it will start oscillating like this, and this at any location, the displacement this is written by ux comma t, because this displacement will be a function of x also. You can see here it is 0 and here it is something, so that means it is depending on x, and it is depending on t also, because if you are watching this movie you will see that at same place the displacement is changing, so that's why this displacement u is a function of position and time, correct? So now what is the equation governing this? What is the equation governing this uh, uh, displacement? So the equation governing this displacement is a wave equation that we are going to solve, correct? So what is that wave equation? That is c square uxx is equal to utt, where the symbols have usual meaning. This double derivative means, this double x means double derivative, and this double t also means double derivative. Okay, correct? So we have to solve this equation by using the technique which we have already known. So what I will do, you can see from here that this c will represent the velocity. So this c is wave velocity by which the wave is traveling, but this there is another velocity of this also. This displacement has also got a velocity that will be represented by u dot. Okay, so both velocities are different in the wave. So you can see dimensionally also, suppose u has dimension of u and this double derivative will be L square. Again u has dimension of u and this double derivative will be t square. So you can see that c square will have dimension of L square by t square, which is velocity. Okay, so this will represent the velocity of the wave. Correct? So now we want to solve it, and you can see that the x is limited between 0 to L and time will be taken greater than 0 starting from 0. So this equation is one dimensional, undamped, because there is no damping term. Damping means velocity term. U dot का term कहीं भी आ जाएगा, so that will be the damping term. वो मैंने आपको simple damped oscillator के case में भी I have explained that to you in the case of damped oscillator. So forget about this. This was just a dimensional analysis. Now see, this is the equation which we have to solve. Okay. So what will be uxt as a first step? That will be some function of x and some function of t. Uxt will be some function of x and some function of t. Correct? So this will be given by c square t times x double dash is equal to, so here if you will take double derivative, partial double derivative, so t will not be, t will just come out and double derivative will be of x, and here x will come out, double derivative will be with respect to t. Everybody understands this?
Yes, sir.
Yes, sir.
Very good. So now separate the variables. X double dash by x is equal to t double dot by c square t. This is a standard form. You can always argue कि c square यहाँ भी रख सकते हैं. Yes, रख सकते हैं. But this is the standard form that you will see will come out of this equation. Now here it is only function of x and here it is only function of t. So this side I will write minus lambda square as a constant. Why I am writing minus and why I am writing square? Minus because when I will equate to this equation, this will become a sinusoidal equation. That is our preference. But there is no compulsion. अगर आप plus भी लिख देते हो, so that will be not a famous form, but that will also be correct. Okay. So let us write the two equations out of this. So x double dash plus lambda square x is equal to 0. This is the first equation. And second equation is t double dot plus c square lambda square t is equal to 0. This is the second equation. The solution from this will be given by, now because of our previous experience we can write it quickly, a cos lambda x plus b sin lambda x. Correct? And what about t? A dash cos c lambda t plus b dash sin c lambda t. This is the equation. Correct?
Yes, sir.
Now we have to apply the boundary condition. I told you that ends of this are not moving, and since it is double derivative in x and double derivative in t, we need 4 conditions to solve. To solve it completely, we need 4 conditions. And you can see also A, B, A dash, B dash. There are 4 equations, or you can simply write CD if you don't want dash. या ठीक है? Is that okay for you?
Yes, sir.
Dash को
Sure.
डेरिवेटिव मत समझना. Okay. So
Excuse me, sir.
hello.
Hello, excuse me, sir.
हाँ.
Sir, please repeat that why we take a negative sign here, negative lambda square.
ताकि जब ये लिखोगे तो इस फॉर्म में आ गया ना, तो इसके सॉल्यूशन देखो साइन कॉस के फॉर्म में आ जाएंगे, जो डिफरेंशियल इक्वेशन में हमने किया हुआ है ना ऐसा, डी स्क्वायर प्लस लैम्डा स्क्वायर,
Yes, sir.
तो उस फॉर्म में आ जाए, साइन कॉस के फॉर्म में आ जाए. अदरवाइज अगर ऐसा नहीं लिखोगे तो वो एक्सपोनेंशियल फॉर्म में रहेगा. ठीक है. बट नंबर वाइज दोनों में कोई डिफरेंस नहीं है. ये वो फॉर्म है जो किताबों में हर जगह नजर आता है, तो हम ऐसे ही फॉर्म को लिख लेते हैं. ठीक है. अदरवाइज ये तो नंबर है, दिस इज अ नंबर. सो according to boundary condition the value will come same, that will not be affected. Correct. But देखने में फर्क होगा. आई बात समझ में?
Yes, sir. Thank you, sir.
So अब देखो जरा, let us apply the conditions, 4 conditions. The first condition is that u of 0 comma t is 0 because the ends are tight. So at x is equal to 0 there will be always a 0 displacement, and at L also there will be always a 0 displacement. देखो जरा ये बात समझ आती है? So let us apply these 2 conditions first. This condition means ends are not moving. Ends are tight. They are not moving. It means that. Okay. So apply करना जरा. What does this means? X of 0 into t of t is 0, which implies x of 0 is 0. This is the first one. So if you put it here, 0 is equal to a plus 0. So that means a is equal to 0. The result of this is a is equal to 0. And second one, if you apply x of L into t of t is 0, that gives you x of L is equal to 0. So if x of L is 0, your x is now b sine lambda x. So x of L is 0. So 0 is equal to b sine lambda L. That means sine lambda L is equal to sine n pi. That means lambda is equal to n pi by L. So what is the value of x now? B sine n pi x by L. This is the value of x. So now what is the value of u? The value of u x comma t is given by summation n is equal to 0 to infinity, because here the value of n will be 0 plus minus 0 1 2 3 up to infinity, all values. So here I am writing this and this now. So I am writing this as an cos c, एक मिनट, c n pi t by L plus plus bn sine c n pi t by l into sine of n pi x by l. So this is your final solution of this partial differential equation. अब मैंने ये डैश वाले कोफिशिएंट्स के बजाय a and b n ही लिख लिया है because of ये a और b तो कहीं यूज होने वाले हैं नहीं. So just to write the final form into more known form. Otherwise you should write dash here. Okay. And n, this suffix has come because the values of n will vary from 0 to this, so you will be the superposition of all the values. That's why.
Hello, sir.
हाँ
Sir, you said 4 equation need. There is only 2 boundary
हाँ,
conditions.
so two constants are still unknown, na?
Okay, sir.
So this is the form which we should remember, because if suppose some string question is asked, so then we can't afford to derive all this. But we should remember that if your equation is c square uxx is equal to utt and the ends are tight, so using those boundary conditions you will get the value ux comma t is equal to summation n is equal to 0 to infinity an cos cn pi t by l plus bn sin cn pi t by l bahar sin n pi x by l. So this form we should remember, then only we can solve question in exam. And this is very easy to remember if you see the symmetry. This has to be dimensionless inside. So ऊपर भी देखो distance है, नीचे भी distance है. Velocity into time upon L. And here x is there, L is there. Because sine and cos has to be dimensionless. So now if a question is asked, they will give two more conditions that will be new to the question, and that will tell you about the boundary condition, and that will be initial displacement and initial velocity. Two more conditions will be given in the form of initial displacement and initial velocity. एक बार यहां तक में किसी को डाउट हो तो बताओ.
हेलो सर.
हम्म
सर यहाँ मतलब n टेंस टू 0 टू इन्फिनिटी कर दिए हैं.
क्योंकि ये वैल्यू सेटिस्फाई होगी n के सारे वैल्यूज के लिए.
यस सर.
फॉर ऑल द वैल्यूज इट विल सेटिस्फाई.
यस सर.
सो तुम कौन सी वैल्यू लोगे? विच वैल्यू यू विल सेलेक्ट? सो आई हैव, that means कि it will be superposition of all type of harmonics.
ओके सर.
So देखो ये मैथमेटिक्स और फिजिक्स कैसे साथ साथ चलता है. Because there is a condition like this, so that's why all type of mixed superimposed waves is seen in the solution.
ओके सर. थैंक यू.
So I'm erasing this. So suppose the equation was a square uxx is equal to utt, correct? Where the value of x was between 0 to l and the value of t was greater than 0. This was the equation. Like, so what is the value of u? You should be able to write it immediately. Summation n is equal to 0 to infinity cos a n pi t by l plus a n plus bn sin a n pi t by l bahar sin n pi x by l. This should be the solution which you should remember. Now two more conditions will be given. As I told you, third condition is u of 0 comma t. ये क्या है? Sorry, u of x comma 0. What is this?
टाइम.
Initial displacement. Yes. So this is suppose u of x comma 0 is given, suppose some fx, and obviously this will be only function of x because time is 0, correct?
Yes, sir.
And fourth condition will be ut of x comma 0. This is gx. Two more conditions will be given. This is called initial velocity. If you can see, this t represents the derivative, so ut represents the partial derivative. ये नोटेशन बड़ा अच्छा हो जाता है ना यूज करने में, डेल नहीं लिखना पड़ता. बट सभी लोग समझ रहे हैं ना? ut means
No, you better it is.
del u by del t. So this notation is so comfortable that once you start using, आपको मन नहीं होगा del वेल लिखने का. Okay, correct? So these two are given and they will calculate the value of this. So please uh, uh, let us apply this and get the value of an and bn also. So what will be the value? Let us apply the first one. The value of ux comma 0, that is fx, is equal to, if you put t is equal to 0, what will happen? It will become summation n is equal to 0 to infinity an sine of
Multiply sin
n pi x by l. Correct? This is the value of fx. And अभी मैंने पढ़ाया नहीं है, but this is actually Fourier half series. कोई बात नहीं, just नाम लिख लो. This is Fourier half series. Can you see that? fx is written in the form of sine series. या Fourier sine series भी नाम होता है इसका. Sine series. And I want an. So the method is to multiply both sides this sine n pi x by l. On both sides it will become an sine square n pi x by l. All other terms will become 0 if I integrate it from 0 to l dx on both sides. 0 to l dx. So this will become an sine square integral is just upper limit by 2. Upper limit by 2. So what is the value of an? 2 by l integral 0 to l fx sine of n pi x by l and dx. This is the value of an. So if fx is known, that means initial displacement is known. So we know the value of an. Correct? So वैसे मैं डायरेक्ट लिख सकता था ये अगर फुरियर सीरीज पता होता, बट मैंने डिराइव कर दिया. मल्टीप्लाई बोथ साइड बाय दिस एंड इंटीग्रेट इट इन द लिमिट ऑफ एक्स. Similarly, you can calculate bn. For bn, what you will have to do? First of all,
multiply cos.
we will have to take the derivative,
Okay, okay.
and then only you can put t is equal to 0. So the first step will be to write ut x comma t is equal to summation. This will become an pi by l, and cos will become sine an pi t by l. Okay, and plus bn an pi by l cos an pi t by l into sine n pi x by l, just differentiating with respect to t. And now if you will put t is equal to 0, then what will happen? Ut of this, which is equal to gx, g of x will be equal to, this will become 0, it will become bn into an pi by l, and this will become 1, and into sine n pi x by l. So from here, when you write, the value of bn will become, when you integrate it, it will again become L by 2, correct? So L and L will be cancelled, so it will become 2 by a n pi integration 0 to L and gx and sine n pi x by L dx. So this is the value of bn. So hence the value of an and bn are calculated. Please do this as a homework. Simple algebra hai. So do it as a homework to calculate the value of an and bn. Now everything is known. So अगर हम ये एक्सरसाइज पहले से कर लेते हैं, so when एग्जाम में पूछा जाता है तो 5 नंबर का क्वेश्चन 2 मिनट में हो जाता है, because we have already done the background exercise. Otherwise it is not possible to solve. You can see the length and breadth of this. So कोई बात नहीं, एक बार इतना रिवाइज करना, फिर इसके ऊपर हम लोग क्वेश्चन करेंगे आगे, ठीक है? ओके, थैंक यू.